So let's take a look at example 2. Here we have a farmer planning to fence a rectangular pasture that is adjacent to a river. Alright, so let's sketch a picture of that. Alright, so we have a rectangular pasture adjacent to a river, and it says the pasture must contain 180,000 square meters in order to provide enough grass for the herd. So we have our first constraint. The area equals 180,000 square meters. They ask what dimensions would require the least amount of fencing if no fencing is needed along the river. So in other words, we're going to be fencing 3 sides of our rectangle. We want to know the least amount of, we want to know the shortest distance, the shortest total distance that would give the least amount of fencing to preserve the constant area of 180,000 square meters. So what we're talking about is a partial perimeter here for this rectangle. So let's call this X, since it is horizontal, and we'll call this Y, since in this picture it is vertical, and so our perimeter in this case will be X plus 2Y. Now the area is going to be X times Y. So the perimeter is actually the formula that we want to minimize. So I can use the area formula to parameterize one of my variables. So let's do this. Since X times Y is equal to 180,000, let's divide both sides by X and solve for Y. We get Y equals 180,000 divided by X. Now we can go back to our perimeter function, and we only have one variable now. P of X is equal to X plus 2 times 180,000 over X. And that's going to be equal to X plus 360,000 over X. Now we can take the derivative. P prime of X will be equal to, the derivative of X is 1, and this is 360,000 times X to the negative 1 power. Differentiating, we get minus 360,000 over X squared. And setting that equal to 0, we get the following relationship. 1 equals 360,000 divided by X squared, which yields X squared equals 360,000, and taking the square root of both sides, we get plus or minus 600 meters. But our distance can't be negative, and so we discard the negative solution, and we have that X equals 600 and Y is equal to 180,000 divided by 600, and that gives us 300, and these are in meters. So our field needs to be 300 meters by 600 meters, and that will give us the required area and the shortest length of fencing.